this video, I'm going to explain you how to find limits limits in determinate form for type 3 and type 4. Type 3 is of this form 0 into infinity. So now this case arises when we want to find the limits of a function of the form phi x into psi x as x tends to a. If limit of this one is of 0 into infinity form, then we can always reduce it to either of 0 by 0 form or infinity by infinity form. So you can see that if limit x tends to a phi x by psi x is of 0 into infinity form, then you can express this one as phi x upon 1 by psi x, which reduces to 0 by 0 form, or you can express it as psi x upon 1 by phi x, which reduces to infinity by infinity form. So then after reducing it to either 0 by 0 form or infinity to infinity form, then you can evaluate the limit of this given function by the method that we have done for the case of 0 by 0 form, that is L'Hopital rule, and also for the case of infinity by infinity form. So when you have this type of problem, that is limit x tends to a phi x into psi x is of 0 into infinity form, then first step what you need to do is reduce it to either 0 by 0 form by expressing it into this form, or infinity by infinity form by expressing it in this form, psi x upon 1 by phi x. Now next type will be of this one, infinity minus infinity. So how to find out the limits of this one? So if limit x tends to a, phi x minus psi x is of infinity minus infinity form. That means if limit x tends to a, psi x is infinity, and limit x tends to a, psi x also is infinity, then what you need to do, you can reduce it to 0 by 0 form by using this rule, that is you can express it as 1 upon psi x minus 1 upon phi x divided by 1 upon phi x into psi x. You'll see that this 1 upon psi x will be 1 by infinity, so it will be 0, minus 1 by infinity also will be 0. So it will be, the numerator will become 0. Now, in the denominator, you have 1 upon phi x into psi x. This is infinity, infinity. 1 by infinity will be 0. So it reduces to 0 by 0 form. And the limit of this function, x tends to a phi x minus psi x, can be evaluated by L'Hopital rule. So we'll follow this rule in order to find out the limits of the function of type 3 and type 4. So let us solve this problem, or we can write evaluate limit x tends to 0 x square into log of x square. So now let us see this problem. Evaluate limit x tends to 0 x square log x square. So directly if you find the limit of this one, then limit x square as x tends to 0 will become 0, and log of 0 square, that is log of 0, is infinity. So this one is of 0 into infinity, that is of the first type 3 of which is of this form. So you have to express it in this form, phi x upon 1 phi x divided by 1 upon psi x, or psi x into divided by 1 upon phi x. So you can reduce it to either the first either this form or this form in order to evaluate the limit of this. So solution will be limit x tends to 0 x square log of x square is of 0 into infinity form. You can write since limit x tends to 0 x square, this is 0, and limit x tends to 0 log of x square will be equal to log of 0 square, which is equal to infinity. So it is of the 0 into infinity form. So you can reduce it to either 0 by 0 form or infinity to infinity form. So in this case, I can write as limit x tends to 0. Let us keep this log x square in the numerator, so that means infinity will remain there, divided by 1 upon x square. So you can see that this will become infinity, then 1 by 0, it will be infinity. So which is of infinity by infinity form. So we can use that form 2 or infinity by infinity form in order to evaluate this one. So now what you need to do is you differentiate the numerator separately and the denominator also separately. So if you differentiate the log of x squared, then in that case you get 1 by x squared into differentiation of x squared will be 2x. And if you differentiate minus 1 or differentiate 1 by x squared, then you get minus 2 into x to the power minus 3. So let us simplify this one. It is limit x tends to 0. It is 2x by x squared divided by minus 2 by x cubed. So this 2 and this 2 will be cancelled. 1x here also will be cancelled. It reduces to limit x tends to 0. 1 by x or minus sign will be there divided by 1 upon x cubed. And this is equal to limit x tends to 0. I can take out that minus sign, minus limit x tends to 0. Now x cubed will come to the numerator, so it will become x cubed by x. So you can cancel this one, which reduces to minus limit x tends to 0, x squared. So you see that the denominator of this one now is a constant, which is equal to 1 being a constant. So you can find out now the limit of this one by substituting x by 0. So it will become 0 square, which is equal to 0. So finally we have limit x tends to 0, x squared log of x squared is equal to 0. So you see that this 0 into infinity form can be reduced either to infinity by infinity form or 0 by 0 form. And then to evaluate that one, you have to apply the rule of L'Hopital rule if it is of 0 by 0 form, and then the rule of infinity by infinity form. Now number 2, the example for type 4. That is infinity minus infinity form. So let us evaluate this limit x tends to pi by 2 secant x minus tan x. Now we know that what is secant x? It is 1 by cos x, and cos of pi by 2 is 0. So 1 by 0 will be infinity, and tan of pi by 2 again we know that it is infinity. So this one is of infinity minus infinity form, that is of type 4, or infinity minus infinity form. So solution is limit x tends to pi by 2 secant x minus tan x is of infinity minus infinity form. So what we can do now, we have to reduce it to 0 by 0 form, that is of form type 1, in order to evaluate the limit of this one. So this is equal to limit x tends to pi by 2. Now we know that secant x is equal to 1 by cos x minus tan x is sin x by cos x. Let us simplify first this one before we reduce it to 0 by 0 form. Then it will become 1 minus sin x divided by cos x, since the denominator is same for both, that is cos x. Now let us see in this case. If you replace x by pi by 2, then what is sine of pi by 2 will be 1. So 1 minus 1 will be 0. And what will be cos of pi by 2 will be 0. So you see that this one is of 0 by 0 form. And this can be evaluated by using the L'Hopital rule, that is you differentiate the numerator separately. So if you differentiate the numerator, differentiation of 1 will be 0 minus differentiation of sine x will be cos x divided by differentiation of cos x will be minus sin x. And this is equal to limit x tends to pi by 2, then minus cos x by sin x. Minus minus will be cancelled. So this is equal to limit x tends to pi by 2 cos x by sin x. Now let us see, if we replace x by pi by 2 in the numerator, cos pi by 2 will become 0, but in the denominator sin of pi by 2 is equal to 1, which is not equal to 0. So you can directly now substitute. It will be limit x tends to pi by 2 cos x divided by limit x tends to pi by 2 sin x, which is equal to cos of pi by 2 divided by sin pi by 2 which is equal to 0 by 1, which is equal to 0. So finally, it implies that limit x tends to pi by 2, secant x minus tan x is equal to 0. So hope it is clear now for this type 4 and type 3 and type 4, how to evaluate the limit of this type of function, that is of 0 by 0 into infinity form and infinity minus infinity form. For type 3, you have to reduce it either to 0 by 0 form or infinity by infinity form by expressing it in this form. And then for type 4, you have to reduce it to 0 by 0 form, that is by expressing this phi x minus chi x as 1 upon chi x minus 1 upon phi x divided by 1 upon phi x into chi